welcome to this video. Today we want to discuss about the problem number 5 of our internal assessment. The problem says that the using Larmor formula, that is the power formula of this uniformly accelerated charge particle radiation. Okay, this is the Lamar's formula of a power radiation of a moving charge particle, that is the uniformly accelerated moving charge particle. Derive the expression for the uh, Lorentz formula for the radiation reaction. Okay, discuss the above problem of Lorentz formula. Then this is the next part. They discuss the problems of this formula, and the third part is the write down the limitation of the critical equation. So these three parts of this question. Consider if this is a particle, charge particle, and if we apply force, this must be acceleration. Okay, and it also radiated. That's mean this total applied force not equal to mass into acceleration. This force must equal to this mass into acceleration plus radiation force. So the radiation energy comes where, from where? This radiation energy comes the due to applied force. This is the applied force. The applied force comes into two role. First one is it accelerates the particle, and second one is it radiates the particle. Okay, so we need to find out the radiation force, the force which the component of this force, applied force, which converted into radiation of this charged particle. This is the known as the radiation force by reaction force. This reaction force was found out by the Amber-Lorentz formula. Okay, the electric field of this charged particle and the magnetic field of the charged particle is mentioned about this in the problem number 1. Is the in problem number 1 you got the expression of this electric field and the magnetic field is like that. Okay, so it is not only in the term of the 1 by r contributed to the radiation in the measure in the Lamar's formula. In case of the Lamar formula, that is the non-relativistic case. Lamar formula means this is the non-relativistic. In case of non-relativistic case, this formula, Lamar's formula, says the power distribution of a charged uniformly charged particle, and the other term, that is this term, is known as the component of B, falls as the 1 by r square. So the contribution is nothing the integral of the Poynting vector over a large sphere. Since it get the multiple into the either another term of this 1 by r square and this 1 by r in this. So this is the velocity field. In this in the using this electric field and magnetic field, if you calculate the power, this is the Lamar formula of this formula, and if you want to find out the power, in this power, power is nothing but work done per time, work done per time, and work done is nothing but force into displacement by time. This is F dot F. So the total power is nothing but F dot T. This is the energy power, and if we multiply by T, so this is comes into the energy. So if we integrate by these by parts, and you get this expression, and if you comes into the similar same side, you get this is the radiation power for radiative force. That means the force associated with the radiation reaction of a moving charge particle. Okay, this is known as the Amber-Lorentz formula, and by this formula you get the radiation reaction force. Okay, and next one is the what is the problem of this force. Suppose you consider a situation where the acceleration is constant, that means a dot is 0, the charge is radiate, but the radiation becomes reaction is 0. When the acceleration changes is 0, that's a uniform acceleration, the charge is radiated but the radiation reaction is 0. In the another case, if considered a is 0 but a dot not equal to 0, if we consider this case, so you get there is no a is 0, there is no radiation, but there is a radiation reaction. Okay, so this is can be happen, but this is not a possible, because if the velocity must be 0, though if there is no external force, the velocity must be 0. that is the acceleration, and the derivative is also 0, that's the radiation also be 0. This must be also 0. If the A equals to 0, that is no applied force is applied, then this will be a 0. Okay, and the general case, if you consider the mass into acceleration, there is two force, there is the radiation force and the applied force. The radiation force part is this, and this is the applied force. And if we got the total acceleration is like that, if we integrate it, then you get that there is a pre-acceleration. Pre-acceleration means the charged particle is considered as a pre-acceleration, where we take the time is where the starting of the time, before that there is a acceleration occur. This is the time t equal to 0, but the acceleration already boost up. This is the velocity dot v dot, that is the acceleration. This is the acceleration. The acceleration is pre-acceleration, the acceleration which are occur at the time t equal to 0. This is the pre-acceleration. Pre-acceleration. This concept helps us to realize the or solve the problem of this equation. Okay, and this is the limitation of the classical electrodynamics. The limitation is nothing but the for classically former always smaller than the later of this factor omega naught tau is the factor for which uh, the classical is former for this reason. Okay, and the classical electron orbiter is small and the electric strength are alternative. In case of failure of the classical electrodynamics, there is a quantum electrodynamics is happened, and in case of the energy is like that, the field becomes infinity and take equals to, if r tends to 0, the electric field. This is the problem. Actually lot of complicated in this look it is. So this is the problem when r tends to 0, so u becomes infinity. This is the problem. So this expression will change in case of quantum electrodynamics, and the end of the classical electrodynamics comes into the quantum electrodynamics. This problem will be solved in the quantum electrodynamics. Okay, thank you for listening.